This is Weiss with another video of mine here. Today discussion is about the weight and balance FAA written test for private pilot, but it 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 can be useful for commercial pilot too. So please pay attention, and these questions are really good questions that later on you could use them. Um, so. Let's go from the beginning. We have 22 questions here, um, and I have this here notepad on the right. Same thing. Use it as a notepad, and then I have these questions on the left that we have to go through. So let's go through number one. Which items are included in the empty weight of the aircraft? Very simple. We said that it's unusable fuel and undrainable oil. These are the ones that we cannot basically get it off the plane. So let's go to the second question. In conducting a pre-flight, the PIC responsible is to use. Let's take a look at the most current weight and balance data. Weight and balance data from the factory. Recent weight and balance data. So I would say the most current one because anything could been changed within the plane. If A and P mechanics taking out stuff, they have to redo weight and balance. So the most current one is the most accurate one that you have to go through. So finally, let's get to some calculations here. Weight and balance here. Um, an aircraft is loaded 110 pounds over the maximum certificated gross weight. If fuel, basically gasoline, is drained to bring the aircraft within limits, how much fuel should be drained? Well, it's very simple. We know that each gallon is 6 pounds, so why don't we divide 110 pounds into 6? 110 divided by 6, and we can see how much it is. That's going to give me 18.33 gallons, so most likely 18.4 rounded up, and we are correct. So let's move forward. This question here is a little bit more complicated, but it's not that complicated. So it says, what is the maximum amount of baggage that may be loaded aboard the airplane for the center of gravity to remain within the moment envelope? So basically it's saying that how much more baggage you can load so you can stay within this envelope. Okay, now we have a couple of answers here, but we will work it out. So this question needs a little bit of work here. So let's say they give us our empty weight, so we're gonna jot that down, 1350, and then moment we have 51.5, and it's in thousands, so 51.5 in thousands. And then we have pilot and front passengers. We have weight of 250 pounds, and we don't know the moment, so we'll look for it later on. And then we have rear passengers, 400 pounds, and we'll look for the moment. Baggage, same thing, don't know, so let's write baggage B. And fuel now we have 30 gallons. Okay, 30 gallons of fuel. We know that each gallon is 6 pounds, the way we just discussed. So if we multiply 30 by 6, we 180 pounds of fuel on board we have. Okay, now oil, 8 quarts, and we know already moment is -2, so we're gonna put the oil. 8 quarts is 15 pounds. And if you go to this uh, view figure here, you can see right up here, engine oil, 8 quarts, 15 pounds, and -2 moment divided by thousands. Okay, so we know that, and it's the moment's minus 0.2 by thousands. Okay, so now we know all these um, questions here, whatever we got. So let's go back to this figure. We're gonna go to this here diagram, and it's loading graph here. Let's say we're trying to look for the front passengers here. Front pilot and front passenger 250, rear passenger 400. So, oops, actually go back. Show figure, show figure, show figure. Alright, so I'm gonna zoom this in a little bit. So we know that it's about 250 pounds is right up here. Come down 250 pounds front passengers and right up here. So it's about 1.5 down here. So we come up here. So it's about 9. We have to write down 9 in moments. 9 divided by thousands, right? So write 9 on that, and then we're gonna find the 400 pound rear passage. We can come all the way down, and that's 400 pound rear passengers all the way up here with a bigger line. Come down, so it's about 29 there. And then we have, what is this? We have, let's get the fuel first, baggage. So baggage, how much baggage we have to load here. So let's get the fuel, 180, it's about 150, 60, 70, 80, and then come down all the way to the fuel. And let's say a little below that, so come down, so about 8 on fuel there. Now we need to know how much baggage we can, but in order for us to know how much baggage we have to add here, we have to know where we add first of all. So we're gonna go ahead and add all these weights and then add these moments. 1350 plus 250 plus 400 plus 180 plus 15 equals to 2165. And then moment 51.5 plus 9 plus 29 plus 8 equals minus 0.2. It equals 97.3. 97.3. Alright, now we can our weight is 2165. So 2165, more like there. I come back here, 97. So there's 95, 97.3. Coming down, come up. I need a 2165, so right there. So we are exact within the envelope, and it says how much baggage um, you can load. So I would say if we take 120 pounds or 105, let's say 105 pounds. Um, if we do 110 pounds, let's start with this. So 110 plus 2165 would be 2275. So you go to that graph and see um, 2275 would be all the way around here, and then obviously your moment's gonna be 100 pounds of baggage would be about 9. So add this to 9 would be 970 97.3 plus 9 will be 106.3. And then we did 100 here. Let's say what do we got? So we got 2265. So if we come up here, um, we know that we got 2265, something like that. And then we have 106, 105, 106. So still within the um, envelope. Could be within the envelope, and that is, could be within the envelope. But let's say 2165 and 97.3 at 105. So obviously this 105 will work because this one, if so, we don't have the what's his name? We don't have exact calculation. We don't have exact measurement that comes down, but I'm just trying to show you the general way how you're gonna do it. So it looked like it was right within the right in this corner of this envelope. 106. Oh, actually, that was outside. It would have been outside. So it's not that accurate. If you print this chart out, it'll be a lot more better. So let's say 100. That was actually even 110. It wasn't 100. The answer was 110. So if it would have been 100, it would have been inside the envelope. So um, let's let's show 105. 105 should be right here somewhere, and then come down to a baggage right around here. So about 10. So it will be about 10 here. 105 was really 10, so 107.3, and that would be 220, 2270, and so that's gonna be 2270. Okay, 2270, and then you got the 107.3. So if you come down here, 2270, 2270, right around there, and you're gonna come up 107, 105, 107, right in this corner. So that means the 105 is perfect, at least one out of 110 and 20. So if you would have picked 110, it would have been out of the way. 100 would have been perfect. 105 is on the border, which is acceptable. So there we go. That is that for your for the for this question. So yeah, it was my mistake. I thought it's 100, and I was like, okay, 100 is within the limits to what's going on. Can be right, and I guess I missed the 10 point. All right, so 10 pound. All right, let's go to the next question. All right, it says if an airplane is loaded within the CG forward of the allowable range, okay, forward, what's going to happen? The pilot needs to use more back pressure, the elevator to hold the nose up. The pilot needs less back pressure. The pilot needs to use more right rudder. This one does not make any sense. This last question, this one doesn't make sense. So skip that quickly. Unlike automobile, your airplane can only be loaded if the load beyond the maximum level of weight, or experience. Uh, so these are very simple questions. I'm going to skip that. What is the maximum amount of baggage that can be carried when the airplane is loaded? As follows. Okay, so this is same simultaneously. Actually, this one is a little bit different. So let's figure this one out real quick. How can we figure this one? Is we will just put front passengers. Okay, your front passenger, 387 pounds. Then you got rear passenger. Rear passengers, 293 pounds. And then fuel, you have 35 gallon, equals to multiply by 6. 35 multiplied by 6 would be 210 pounds. Okay, that's what they give us. So it says, what is the maximum amount of baggage that can be carried when the airplane is loaded? As follows. So how much baggage? How many pounds? So first of all, we can go here. We can go to this table of content. We can find our empty weight of the aircraft 2015. Empty weight is 2015, and your moment is by hundreds, 1554. Okay, that's perfect. Now take a look at this. Front passengers, we don't go that high, 387 pounds. So let's multiply by arm that. Multiply by 85 equals your moment. So 387 multiplied by 85, you get 32,895, which is divided by 100. Divided by 100 equals 328.95. Say 329. That's your moment. Alright. So your rear passengers right up here. Column does not go 293, so multiply by 121 equals this this is example, okay? So when I say does not go below, our weight is a little bit higher than 200, so just multiply by the arm and you get your moment, and that moment is divided by 100. Hope you understood. So let's say we got 293 here, multiplied by 121 equals 35 divided by 100, so 354.5. there. And then we have 210 pounds. 210 pounds multiplied by, what is it, fuel, usable fuel, by 75. 75 equals um, um, 157.5. Alright, so we got these, and then see how much baggage we can add into whatever I have here, because people come with their baggage, luggages, okay? And this is going to be table of baggages, okay? So, I'm going to go back to this question. It said 220 pounds, 45, 63. See if I can have that exactly here. 63, 225, 225, what is it? 220, 45, 63. 220, 45, 63. 220, 45. We don't have that. And we don't have 63. Alright, let's first add all the weight right quick. So we don't 2015 plus 387 plus 293 plus 210 equals to, the total weight is 2905. Your moment is 1554 plus 329 plus 354.5 plus 157.5. That will be 2395. Okay, 2395. And if I divide that by 2905, I can get my center of gravity, 82. Arm is 82. Okay, so if I go to the second table here, the second table, see if I get the 2905 on my weight. 2905. We can go all the way up here. 2993. I can go all the way up here because of my 2395. So 2930, 2940, 2950. See, it's 2950 up to where. So let's add 45 pounds, okay? Let's add 45, see what happens. So 2950, if I add 45 pounds, that's the total there. And then if I have that 45 pounds of baggage, would be about, oops, not this one. So about 50, so let's say 50, 70, interpolate between 70 and 56 would be how many? It's say about 14, 14 divided by 2, 7, so 42 plus 7 would be 49. So let's say 49 in here. See what happens. 2395 plus 49 equals 2444, and that's 2950. And if I go back to this, 2950, so come up 2950, it's between 2422, 2499. So we are exactly within the limits here, 2950, and my minimum, we are within maximum. It should be good 45 pounds. If I get 63, it's probably going to get even worse. It's going to get higher. Perfect. Going to the next question. Next question is the same, basically, almost the same. So I hope you guys understood um, the general meaning of it, how it's done. All right, and let me get this pencil cleared off this thing. Okay. All right, perfect. So it says next question is which action can adjust the airplane's weight to maximum gross weight and the CG limits for the takeoff. Same thing, you put down all these numbers here, and um, go here. Same thing, just it's the same almost question, so I don't have to go through this one. You can think about that. Let's go to the next one. Is loading an airplane to the most of CG, most aft CG will cause the airplane to be. Obviously, if think about it, if you have the um, let's say CG is all the way aft here, what's gonna happen to the airplane? You, your flare will be good, but less stable. Stable at low speeds, but more stable at high speeds. Less stable at high speeds, but more stable at low speed. Less stable at all speeds. Which one you guys think of? This is CG. So what do you guys think of? It's less stable at low speeds, but more stable at high speeds. If you go faster, your most FCG will be it will give you most. It's less stable, obviously, but less stable at all speeds. Do not forget that. But more efficient, fuel efficient. Um, for economy is very good, but stability is not good. Okay, you're more stable at uh, forward CG. That's where you're more stable, not aft. Aft's just efficiency is better, fuel economy is better. Okay, let's move on to the next one. This I think same similar question. And I can tell you exactly. You put all these numbers here on this side and um, grab your put all these numbers here and then multiply by your arms, and then once you get that, just go ahead and compare it in here. Your weight and your moment should be within these numbers, minimum and maximum. If it's not, then you're not good. But since I've done this question uh, a while ago, and I know that my weight was within limits and CG was out of limits. So, oops, yeah, that's the one. So, it's going to be the same thing. What is the maximum amount of fuel that may be aboard the airplane on takeoff if loaded as follows? Same thing, you just put in all your um, weights, moments, add it up, and see how much um, fuel you should have on it. Now, this one is a little bit tricky for new guys, but it's very simple if I reveal it. You determine that your airplane is 90 pounds or maximum certificate gross weight. How much fuel, avgas, must be drained to bring it within the limits? So you're 90 pounds or the maximum certificate gross weight. What do you need to do? You have to know its weight, right? You have to see how many gallons because this is gallons are right up here. This is 90 pounds divided by 6 equals probably, I'm not sure. 90 divided by 6. That's going to be your equals 15 pounds. Gallons, I'm sorry. And that's your answer. Okay, very simple answer. This question, we have weight and balance that we have so many repeated questions or similar questions or very similar. Very similar questions coming over and over, which I'm not going to waste time. I just give you um, the example how you should do it. So keep doing that. Uh, and this one is very interesting. So I would like to see what's going on here. So it says upon landing, the front passengers 180-pound departs the airplane. A rear passenger 240-pound moves to the front of passenger position. What effect does this have on the center of gravity if the airplane weighs to 26 90 pounds in the moment 100 divided by 100 was 26 was prior to passenger transfer. So basically, the airplane landed, and at the gate, the one fat guy got off. 180-pound guy got off the plane, and then the fat guy tried to get to first class to eat a lot of meals, and messed up all the CG within the CG, and pilot is now wondering what's going on, what happened. It's the same thing, just put the formula down, put your, see, put this guy under the passenger, front passenger, this one rear passenger, and then everything else will come in its place, and solve it that way. So, but the answer that I've already came up with is 3 inches forward CG. So the CG moves forward 3 inches because this is heavier guy, so he moves forward. CG moves forward. All right, but remember, guys, I'm not skipping. This is same similar question test. You have to use your head to answer this. Okay. I gave you a couple of examples. I'm not gonna go through every example similar. Otherwise, I'm gonna be sitting here till the morning, answering similar questions. All right. So it says the next question, 15th. What effect does a 35-gallon fuel burn main tanks have on the weight and balance if the airplane weighs 2890 pounds in the moment, 124 52 at takeoff? So here's the thing, okay? So 35 gallons subtract out of, let me see here. So what you do is basically, it's very simple. This question is very simple. Basically, 35 gallons multiplied by 6 is going to be 210 pounds. 228.90 minus 210 pounds would be 0.862, 2680. Okay, and 2680 is 210 pounds. We know it's already answering us. The question is already answering us. And since it's 2680, you took the 210 pounds of fuel off, and then take a look at this thing here. The 210 pounds of fuel coming up, usable fuel. 210 pounds multiplied by 75 equals 210 multiplied by 75 equals 15,750 divided by 100 equals 157.5. And you're going to take off 157.5 minus 2452. So 2452 minus 57.5 equals 2294.5. 2294.5. And now let's take a look at the CG. What happens to CG at this point and then at this point? So at this point we can say 2452 divided by 2890 equals about 84. So this point is 84, and then now we got the new one, 2294.5 divided by 2680 comes up to 85. So 85. So it says the CG goes a little aft. So it goes. So it look like this one says weight is reduced by 210 pounds and the CG isn't affected. That's not our answer. It says weight is reduced to 2680 pounds and the CG moves forward, which is not accurate. It would have been 83. And in this one, weight is reduced by 210 pounds and the CG is aft of limits. That's the one we got. Alright, so that's how you answer. Basically, these when you see these graphs, all of them the same, but I'm trying to give you, if it's a little bit fishier, I'll try to help you guys go through together, Alright, let's go 16. This one's very easy. I know the CG is located how far after the datum. How far after the datum. So you put your weight and all that stuff and then divide it by 2, and then see, divide those by, actually let me do it for you. Some of you guys are like, huh? What is he saying? Come on, do it. Alright, so empty weight is 1495.0. Arm is 101, doesn't matter, 151,593.0. This one is not divided by anything. So for pallet, front passenger 380.0, and then 64 now it matters. So let's go 380 multiplied by 64 equals 24,320. This is arm. And then we add fuel 30 gallons multiplied by 6, 180 multiplied by arm is 96, 17,280. So that's what you got, right? So now plus, let's add all these moments and weights and put it here. So let's say 24, 30, 0, 15, 15, 93.0 equals 193. Okay, now we can add the 1495 plus 380 plus 180 equals 2055. Now, I wish I could have done this for a second. 193193 divided by 2055 equals 94 arms, gonna be 94.01, something like that. So I got exact number right up here. Exact number. So that's how easy it is to calculate this. So let's go with next question. For me to clean this, it's kind of overpaid job here. Overtime going cleaning this thing. Alright, so here we go. What does it say? If 50 pounds of weight is located at point X and 100 pounds at point Z, how much weight must be located at point Y to balance the plank? Okay, that's interesting. Now, this is a new question, so I would like to work on this for you. So let's take a look at the figure, but before that, let's do this. 50 pound weight is located at X, so X is equals 50 pounds. And you got Z, 100 pounds at point Z. Oops, is 100 pounds. And how much weight must be located at Y? So Y is equal, I don't know. Okay, now I'll go back to this figure. So now it says, what are we looking for is Y. We have to look at the Y here, this side. Now, every time you're looking at the whatever you need to find, you gotta look on the opposite side of the fulcrum datum line. So the Z, it says you have 100 pounds. So the distance arm is 100, so we're gonna multiply the 100 by 100. So Z, so let's say this is your fulcrum. This is datum line. So 100 multiplied by 100 is 10,000, 10,000, right? So we know that on this side we have 10,000 pounds. So what do we need to do to make this side balance 10,000? So we have the, now what do we have? X. We have X 50, and then we have distance 50. So let's multiply like 50, multiply 50. How much is that? It would be 5,000, right? Yep, 5,000. I'm sorry, what I'm saying. 2,500. So we only know that. So we only know that, and we don't know why. But we know the distance, the arm. So we know that we are short of this by about 7,500, right? We are short 7,500. So what do we need to do is basically we are short 7,500 on this side, pounds. So we need to divide the 7,500 to 25 to this distance to see how much we are gonna get. So divided by 25 is gonna be 300 pounds. So now we know we divide this by 25 and it equals 300 pounds. So we need 300 pounds in this Y Y CG here, Y position to balance the fulcrum. Okay, so let's come up here, exactly 300 pounds. Alright, good. Hope you understood. Otherwise, rewind the video and keep watching it a million times. And like and subscribe, please. Thumbs up. It's a raw video. I do not update, edit stuff. So, whenever I have time, maybe I go back and edit things up. But other than that, you're getting raw meat, baby. Alright, let's go to the next question here. It says, an airplane has been loaded in such a manner that the CG is located aft of the aft CG limit. One undesirable flight characteristic pilot might experience with this airplane would be, so if you have aft CG, the airplane like a banana, you have aft CG, your angle of attack already is high. It's almost critical angle of attack. And a little bit more, you trying to pitch up, and boom, that's where you get a stall. So it says difficult in recovering from stalled condition. Have you guys seen that 747 took off from Bagram airspace in Afghanistan? If you guys don't know that, then you're illiterate. Don't even watch my videos. Just kidding. So it took off 747, and the way the cargo shifted to the back of the airplane, and that 747 stalled. They could not recover. They tried to push the aircraft forward, and they could not. That aircraft just basically fell like a rock in front of those guys and videotaping, having fun. So unfortunately, they died. So really sorry for them. Yeah, that's unescapable. Just says stalling at higher than normal airspeed, longer takeover. I would say difficult to recover. Okay, this question here is very similar to the previous ones that we went through. Let's take a look at figure. This one, I think we went through this one. Just basically you go through, and for this question, is you need to print these two graphs to be more accurate, because look at this 78.2, 79.2, 80.4. So what you need to do is you find your moments divided by thousands of each of these. Oil is 15 pounds minus 2 moment wise. You just fill them up and then add them, and then you take actually where you find these moments is you say, let's say 380, and you go 380 right up here, 350, 380, and front passengers, just make them cross all the way here and then come down. And whatever you see, 10, 15, 11, 13, that's in thousands. That's your oil right up here. Write them down, and then you can make sure you get, what do you get? Your moment right up here. I'm pretty sure I've done one, but it's better to print the paper and do it that way. Same thing, determine the moment with the following data. It's very, very simple the way I ask. God, give me same again thing. This is calculate the moment. Oops, I hit accidentally. Calculate the moment of the airplane and determine which category is applicable. Utility category. You will come on this graph. You will see it, which category. It's very simple. This one is the interesting one, the one we just worked on. I can work it on again. and this one is the last one. So, how should the 500-pound weight be shifted to balance the plank or on the fulcrum? So, let's take a look at it. Um, so the question is very simple. I don't have to write the note on this side. Basically, present figure says how should the 500-pound weight be shifted to balance the fulcrum. This 500 pounds sitting on this side. So we need to figure out this side first then. So what I'm going to do, I'm going to multiply the arm 20 to 250 pounds, some baggage there. So, oops, 20 multiply 250 equals whatever. And then we're going to 15 multiplied by 200. 15 multiplied by 200 and equals what? So I'm not gonna do this 5,000 there, and then 15 multiplied by 200, 3,000 there, so total is 8,000 on this side of the fulcrum. Let's say you got 8,000. So we need 8,000 to balance this whole thing. Otherwise, it's gonna fall like that. So we have 500 pounds. Let's multiply that. Let's 500 pounds multiplied by 15 equals, God, 15 equals 7,500. So we have 7,500 here. We know that we are 500 short by looking at the 15 inches. Let's add one more inch and see what we get. So let's add a 500 multiplied by 16 inches. Let's say we're gonna just move it to the left a little bit, because we know 7,500. So if we go closer, for some of you guys who think that we need to push this a little bit forward, please think it again, because you got fulcrum right up here, and you need to go back to the 5th grade or 4th. Okay, so the arm is too far if you can look at this side, so I would say 1 inch to the left. So 500 multiplied by 16, and that's going to give us 8,000. Bingo. So it says 1 inch, so add 1 inch to this means move it a little bit further to the left. So that's how you get that right. Clear this up and clear all this up and alright, and then it says 1 inch to the left, 1 inch to the right, 4.05. So we know that's 1 inch to the left. Bingo. Alright, I hope you guys enjoyed the video. More like a professional video. Please keep watching my videos. It's getting better and better, but I'm trying to improve my videos. It's just raw still. They're not being edited, so please don't judge idiotically. So you guys are all grown up people, and whoever is watching my videos, they are awesome. They're learning a lot, and they know that their life is gonna get easier and easier if they watch my video going further on along the road. So I hope I see you guys on my next videos, and yep, keep keep learning things, never relax. All right, you have a great day. Um, See ya.